Okay, good afternoon, everyone. Shahin is here. We wait for a couple of minutes to have more participants coming to class, and then we'll start the first lecture. Thank you. Yeah, while we're waiting, Darcy, can you hear me? Okay, good afternoon, everyone. Welcome to this first lecture of the unit. So all these names are almost familiar to me. I know most of you except Darcy. Darcy, your name doesn't show in the enrollment list. So would you please check that with the student headquarters and making sure that your record would be fixed. Otherwise, I cannot pick your name as attendance in the class. So this is the first class for mechanics of a structure. And today I'm going to have some review from the previous material you had before. But before going through that, I have to quickly take you through the structure of this unit. So if you try syllabuses, that brings you to a new page, and here you can access your unit guide. The unit guide, is a very important document, and it tells you all you need to know about important aspects of this unit. So here we have 72 hours, 12 weeks, combination of the lectures and tutorial. Monday lectures, that would be online, and 2 hours at the very same time. The remaining 4 hours that are split into Tuesdays 8:30 to 10:30, and the next one would be Wednesday 10:30 to 12:30. So during the lectures we cover the theories and some demonstration, and during the tutorial we basically focus on exercising, demonstrating the solutions, reviewing the theories and all that. So in terms of the assessment, I give you more explanation, but that is split into a 20% online, 25% examination, 30% lab, and 25% final exam. Learning outcome, I elaborate this later. Don't want to confuse you right now. Just to stick with the more general issues now. And you find the graduate attributes, the contents in this unit in your unit guide here. But most importantly, I'm the convener. You can always send me email asking me question. Also, I have 2-hour consultation time. Make sure you come to the student hub. During this consultation time, I'll be sitting into TD 140, which is the student hub. You can find me over there in Tuesdays, 10:30 to 12:30. Outside these hours, just send me an email, or you can find me in the TD 195 if I'm there upstairs. And yes, your lectures would be on Mondays. Class 1, class 2 are tutorials. Laboratory works, we have 2 dedicated laboratory works, or 3 2 hours laboratory works. And yes, you make sure you spend enough amount of the time, 6.5 hours per week between week 1 and 12 to master what we do during these lectures and tutorials. So these are the week by week plans, and all you need to know: the starting date, the content for each week, and what are the assessment tasks. Most importantly, there is a break between week 7 and week 6, between 3rd and 17th of April. And 13th of March is public holiday. We make up for the class. And so your first laboratory work is in week 6. Your mid-semester test is in week 7. And your laboratory work 2 is in week 11. Your final exam would be in week 13. So here there will be 3 components of laboratory: 1, 2, 3. And these 30% is a significant change into the subject. In past, the waiting for the final exam and mid-semester test was 35%, 40%. That was too much. And that is not very good for a student, because if you just not feeling well in the exam, you lose a big portion of the assessment. I decided to give more weighting for things that you could do in your free time, such as laboratory work and online assessment. So in another word, if you are engaging enough, you do your weekly assignment, you do the computer lab, you already have passed for this subject. 20%, 30%, 50% is all you need to pass this subject. No hurdle, nothing like that. But then on top of that is the mid-semester test, 25%, and final exam, 25%. So that hopefully has improved the subject, so you get even a greater result. But just keep in mind that this is true for every subject. If you engage, if you come to classes, there is no need for you to worry for this subject. If you just decide to work by yourself, this is a risky thing, because this subject is complex. I strongly encourage everyone to participate in the lectures, come to the tutorials, and that's my recommended approach for completing this subject. So yes, here we start with week 1. That is mostly summarizing the prior material. I'm sure most of you shouldn't have any problem with the scalar vectors, vector operations. And here, force is a good example of the vectors. We want to cover that. Coordinate system, how the vectors can be added, subtracted, operated, and what are the position vectors, force vector, projected over a line, and what is the dot product. These are the topics we cover for this week. Here you find the lecture slide for first class, first tutorial, second tutorial, and here you find some selection of the worksheet. So this textbook, you can buy either the electronic copy or the hard copy. That is a relatively expensive textbook. But the good news is I have digitized anything you need from this one. And these are all you need. Maybe with having access to this digitized material, you won't need to purchase the textbook. All right. So that is every week I've collected the worksheets, digitized them, and put them here. These are the questions we tried during the tutorial, and this is the reading. And that's it. So without further ado, if there is any question, ask me at the onset. Otherwise, I will start the class. And I noticed that as I was speaking, Nigel also joined the class. So let me change his attendance in. Everyone else already, you've been updated. Okay, so now let's get started. Like I said, this week everything is about the summary and everything is about the difference between scalars, vectors. So in this unit, often you have to regard the forces or positions either as the scalar and vectors. And you know the difference. So a scalar is just a quantity. It could be negative, positive, but it doesn't have any direction. When it comes to writing, we have to make a distinction between a scalar and the vector. So we write the scalar by an italic letter like A. Example of scalars are mass, volume, length. They don't have any direction. But when it comes to a vector, it not only has a magnitude, but also it has a direction. If I want to give you an example, you ask me, where is the library? If I tell you walk for 50 meters and then you reach the library, that doesn't make sense, because the next question you ask me is 50 meter in what direction? I tell you walk 50 meter in the north direction, in the east direction, northeast direction, or I have to give you two pieces of information, not only how much you walk, the magnitude, also I have to give you a direction. In terms of the writing, different conventions. Some people use a boldface, some people use a boldface with an arrow on top of it, or different. In this textbook, we are dealing with magnitude, direction, sense of the vector. So length of the arrow is the magnitude of the vector, and the angle between the reference axis and the arrow's line of action is the direction of the vector. So reference axis is the trigonometric circle's x-axis. So the x-axis in the trigonometric circle. So you want to know what this reference axis is. So I tell you, look, this is a trigonometric circle. Let me just make this enlarged. All right, so this is a trigonometric axis, and that is the x-axis. This is y-axis, this is x-axis, and then you have an arbitrary vector force. And then what is the direction of this? So that is my reference axis, x. So you have to go from the reference axis to the vector in the counterclockwise direction, and that is the direction of this vector. So this vector is not only described by its magnitude, so this is the magnitude, also the direction is the angle which the reference should travel in the counterclockwise direction to reach the vector. So that is the direction. So what about the sense of the vector? Sense of vector is shown by this arrowhead. So the arrowheads tell you the sense of the vector. So here, let's start with this example. That is my reference x-axis, and that is my vector. So line of action, or LOA, line of action is very important. So that is the line of action. This is the carrier of the vector. My vector is sitting on top of that line of action, and the angle by which x-axis should travel in the counterclockwise to get to this vector, that is the direction. So this is the direction. What about the magnitude? The magnitude, this is the unit length, 1, 2, 3, 4. So this is 4 unit length. The magnitude is 4. Magnitude is 4. The direction is 20 degrees. And the arrowhead is, this is the arrowhead. This is the sense of the vector, tip of the vector. So these two vectors can be represented by a scalar multiplied by a vector. And if we multiply a number by a vector, what happens? So if you multiply a number a by a vector a, so if this a is larger than 1, that is going to enlarge the vector, doesn't change the direction. If this scalar is smaller than 1, that would shrink the vector. And if that is equal to 1, doesn't change anything. If a is negative, that would reverse the direction of the vector. If a is positive, that doesn't change the direction of the vector. All right, so here this is an example. So we have one vector a. What happens if I multiply that a by 2? Okay, 2 is larger than 1. So as a result, you expect this, the outcome is a times a, which is 2a. You expect this outcome to be enlarged. So this one should be enlarged compared to the original vector. What if my scalar a is equal to minus 1.5? It not only changes the sense, also 1.5 is larger than 1. That would stretch, make the vector taller, but in a reverse direction. If a is equal to 0.5 and multiply that scalar by vector a, because 0.5 is smaller than 1, that is going to shrink the vector, make this shorter. But because this is positive, doesn't change the sense of the vector. So because these are the summary material, I have to go through this very quickly, but feel free to stop me anywhere if you need more explanation, all right? All right, so when it comes to adding two vectors together, so there are 4 operations. The first operation is addition. The second operation is subtraction. The third one is multiplication. The next one is division. So addition of the vectors, it doesn't matter if you add a to b or b to a, both of them would be the same. And here, this is a, b. How do we add the vectors? So the tail of the second vector at the head of the first vector, and from tail of the first vector to the head of the second vector, that is the summation. Or if you change the order according to that trapezoid, you can see that this is b, this is a. So this is a plus b equal to b plus a. So the conclusion is when you are adding the vector, you can change the order of vector, the order of summation. Sometimes this is more convenient to do so. And that is an example showing that a plus b and b plus a, they are all the same. But that is one method of finding the summation. How do we add the vectors? So vector addition, there are 2 ways. The first one is triangle. The second one is by coordinates. Cartesian coordinate, you break the vector into the Cartesian coordinate and add them together. But this is the graphical way, by constructing a triangle. And then by solving that triangle, one way or another, you can find the result of the solution. So imagine I have 2 vectors here, and how do I add them together? So the first thing is I construct a triangle by putting the tail of the second vector at the head of the first one, and then I go from the tail of the first one the head of second one, that is the resultant. So what if I want to add b plus a? Okay, so b, I put the tail of the second one, that is a, at the head of the first one, and then I go from the tail of the first one to the head of the second one, and that is r. So this is b plus a, that is a plus b. And both of them are equal. And then this method of addition, that is called the method of triangle. The easiest way is if you want to add two vectors which are collinear. So in that case, you don't need to bother using the vector. You can treat them as a scalar, and just that's the easier addition of two vectors. If the vectors are collinear, you simply add their magnitudes together. And then this is like a special case triangle. So this is a triangle with A, B, R as the three sides, but in a very special case. What if I want to subtract two vectors? So that is the procedure. If I wanted to add them, I know how to do that, but subtraction, B should be converted to minus B. Minus B is like having a scalar multiplied by B. And you remember I told you about what happens to multiply a scalar by a vector. In this case, minus is reversing the direction, but 1 doesn't stretch, doesn't shrink, so the magnitude remains the same, the sense would change, and now that is how you add them together. So this is A plus minus B, A plus minus B. So I put the tail of minus b here. This is minus b, tail of minus b at the head of the A. And then I go from tail of the first vector to the head of the second one, that is r prime. R prime is the subtraction of two vectors together. All right, the next question is, what happens if there are more than two vectors? With two vectors, yes, we construct a triangle. But if there are more than two vectors, one solution you might suggest is, okay, let me group the first two vectors together, and that group, I take care of it first. So I had F1, F2 group together, and that is the outcome. Now I don't have to worry about this. All I have to worry is the result of that group with the first one. Now this is like a two vector adding together, and that is the resultant, right? But yeah, that's not a feasible way. Imagine you have to add 100 vectors together. What would you do then? So you can't group them 2 by 2 and add them sequentially, right? So this doesn't make sense. So how do we do it then? There is another method which is more suitable for multiple vectors. So yes, if the combination of the forces is easy, if there are only two forces, maybe constructing a triangle is a reasonable thing to do. But if there are many forces to be added, we have to go to a more sophisticated technique. And that technique I'm going to explain next. Before I go further, let me remind you that whatever topic we cover here, they always start from the two-dimensional case. Two-dimensional cases are easier to understand. So once you understand them, we can generalize that understanding to the three-dimensional case. So it makes sense to start from the two-dimension before going to the third dimension. Any questions so far? Okay. No question. Let's have one example problem here. In this example, I'm using a hook connected to a chain to apply the load. So the hook inserts the load vertically, but that chain is breaking the force into two components. And that is what you need. Imagine you are lifting a very heavy object using that chain. So the force by that hook or crane is being divided into two chains, and each chain is taking a portion of the load. So the equilibrium between these three forces, you do have one force exerted by the crane. This force is equal to the reaction of the chain at this point. So at this point, that is the resistance. This is the driving force. So driving force, resistance force, they are equal. That's the third law of the Newton. Action, reaction are equal. And then imagine this force is a combination of the force developed inside the left-hand side of the chain and the force developed inside the right-hand side of the chain. So how do you write the equilibrium between these three forces? So I know that this is a trapezoid, that is FA, also this is equal to FB. So if I want FC, the equation is FC is equal to FA plus FB in a vector sense, or that is equal to FB plus FA. All right, so that is, if I want to calculate that, I need to construct a triangle, and that triangle, I have to keep in mind the angles of this triangle. This is not like a scalar addition, this is a vector addition. So that is called the parallelogram law. Parallelogram law means that triangle is half of a parallelogram. You can deal with the left-hand side parallelogram, or you can deal with the right-hand side parallelogram. So the left-hand side give you the first equation. Sorry, this is the right-hand side. And the left-hand side is if you have FB plus FA. All right, so that is the method of parallelogram or constructing triangle. They are very similar. And these are the procedure for parallelogram law. So this is being summarized from page 40 of your textbook. These are the steps. 1, 2, 3, 4 steps here. The first one, you do need to sketch showing the vectors which are being added together. The second is the two components are added according to the parallelogram law, and you decide which force is being resolved into the two components. And of course, to solve that triangle, you have to label your triangle or parallelogram properly. And then how do you solve that? The solution of that is by using the trigonometry. And I would need to refresh your memory from high school. So how do you solve a triangle? Depending what are the input output, you either use what is called the cos law, or you use the Shine law. So the Shine law is when you have all the angles and the magnitude of one side. So that by itself, how many equations is that? This is one equation, two equation, three equation. But the cos law is when you only have one angle and two magnitudes of adjacent terms. So that is the cos law. This is the Shine law. Shine law, when you use the Shine law, that is when you have all the angles and magnitude of one side. Cos law, you use that when you have magnitude of two vectors and the angle between them. Okay, and then be mindful of that negative side. In a special case, if that angle is 90 degrees, we know that the cos 90 is 0, so that vanishes, and that reduces to the Pythagoras theorem. The Pythagoras theorem is C2 equal to A2 plus B2. That's a special case of the cos law, when you have two, you have a right angle somewhere. All right. Any questions so far? Okay, now we have Serish joining the class. Welcome, Serish, to the class. Make sure you watch the recorded session for the portion that you missed. Just to give you a quick summary, these are nothing new, just all the summaries from your high school, the operations of the vectors, difference between vectors, scalar, and so far we have done combination of two vectors by method of triangle. All right, so the next example, that is, I have provided two forces, and these forces have their angles, and here you want to solve a triangle to find the resultant force. How do you do it? What if I give you 2 minutes, and in 2 minutes you give it a go, and then we try that together, all right? So 2 minutes start from now. Try to combine these two forces together using the method of triangle. Okay, so let's get started. Anyone wants to give me a hint how do I start this? We want to combine F1, F2 to find the solution. So here the question is resultant force is equal to F1 plus F2, and you want the answer by the method of triangle. So before I construct a triangle or parallelogram, what you need is, this is a 90 degrees, right? So 90 degrees, that angle here, which is equal to that one, theta. So theta is 90 degree, take away 15 plus 10. Any objection to that? So this is 65 degrees, right? Okay, 65 degrees. So imagine I construct the parallelogram. So if this parallelogram has 65 degrees here, we know from trigonometry that in parallelogram the opposite angles are equal. So this is going to be 65 also. And who can tell me what is the magnitude of beta? Anyone? 40, can you tell me how to calculate beta? Nigel, Flynn, Chaisal, Ahmad. Yes, well done, Ahmad. According to Ahmad, beta is 115. And how does Ahmad know this one? Because some of these angles are equal to 360. So in another word, 2 beta plus 65 plus 65. That should be equal to 360 degrees. So if you solve that, you find beta equal to 115. So therefore, if I bring that vector here, right? So this is F2. All I have to do is I have to connect from here to here, and that's going to be my R. But according to Ahmad, this angle is 115. So this is F2 is 150, F1 is 100. And to solve this triangle to find R, is this a cos law or sine law? Which one is it? Nigel, do I have to go with sine law or cos law? How this triangle can be solved? So the answer is we have two magnitudes and the angle between them. So that has to be the cos formula. The cos formula is R equal to F1 squared, F2 squared minus 2F1, F2 cos the angle between them, which is 115. Okay, so all you have to do is plug the values and find the resultant vector. So let's have a look at the solution. So here, yes, Ahmad was quite right. The angle between them is 115. And then the equation that we use is the cos law because we have two sides and the angle between them. And then, yes, it's not the only way you can solve this problem. You could have done it differently, but we did that in a simple way, which if you plug the numbers, the resultant force would be 201 newtons. The unit for the force is newton. All right, so let's go to page 44 and problem 2-1. How do we do that? Just let me demonstrate this to you. So here, week 1, you go to here. Okay, 2-1, which one is that we want to solve? That is 2-1. All right, we have an option between A, B, C. You tell me which one you want, and I demonstrate that for you. Just any you want something easy, medium, difficult? Nguyen, you want an easy, medium, or difficult? Just tell me, and I'm happy to demonstrate that for you. Okay, thank you, Nguyen. I do A for you. So here, two forces are given, and we want to add them together. So let's do that together. Do you want to do it yourself, give it a go yourself, or you want me to solve it straight away? Chaisal, do you want to try it yourself, or do you want me to take it right now? All right, I do it myself. So if I bring F2 here, I'm going to have a so that is F1. So F1 has 45 degrees here. And if I bring F2 over there, F2 would be 15 degrees here. So let me find out the angle between here and there. So that angle itself, this is 45 degree, this is plus 15. That angle easily become 55, correct? Anyone is with me? How did I find this angle? Between F1, F2, the angle is 55. So if this is 55 and you construct a parallelogram here, that is 55, this is 55. Altogether, that is 110. And this angle alpha, that is 2 alpha plus 110 is equal to 360. So 2 alpha is 250. Alpha is 250 divided by 2, which is 125 degrees. So in another word, if I, okay, yes, I think I made a mistake. Thank you for correcting me. Thank you for that. That was just on time. Thank you. This is not 55. And I just see that this was Chesa. Well done, Chesa. That's glad you are paying attention to things. Okay, so this is 60. This is 60. That is 120. So that makes 240. 240 divided by 2, that is 120. So 120 is this angle. So if I bring that force like so, that is F2. And now from tail of the first one to the head of the second one, that is R. But this angle we calculated to be 120, right? And Chesa, do I use the sine law or cos law? Or how do I find R? Do I use the sine law or cos law? The answer is cos law because we have F1, F2, and the angle between them. That is 110 squared plus 200 squared minus 2 times 110 times 200 and multiplied by cos 120. Okay, so that gives you the magnitude and the direction of the R. How do I find the direction of R? All right, questions? All right, the next slide, we have an example here. It's a big steel pipe. And here we have a bracket fixed at one end of the pipe. And then a force of 1000 Newton is exerted in the direction which is shown. And then you want to resolve that force into X component and Y component. So how do I resolve the forces? So again, that's a thing we learned during the high school. So if I want to resolve that one into x-axis, all I have to do is I need to construct a right triangle. So in that right triangle, this is the x component, that is the y component. So this is fx, and that one is fy, or this one is fy. And this angle is 40. So this is very simple. So 40 degrees here, that is fx, this is fy, and that is 1000. So how do I solve that? This right angle is fx is equal to 1000 cos 40, and fy is 1000 sine 40. So to solve that triangle, this is a skill you have to repeat this many times in this subject. So if you are rusty with trigonometry, that little triangle, just try to perfect it for yourself. Otherwise, you will have a hard time in this subject. Make sure you know how to solve a right triangle, given the angle, the hypotenuse, the normal side, you should be able to solve the triangle. That is something you want to make sure you perfect it, and you can do it with a closed eye. Okay, no kidding. So you should be able to solve this with a closed eye. That is a prerequisite from now on. We have for solving the forces resolved into the component. Any question? All right, no question. Let's move on. So that is how we resolve that into the component. Imagine that there is a second coordinate system, x prime, y prime. So how do I do it then? If I have a new coordinate system, x prime, the difference is this time 1000 should be projected over this one, and then the right angle would be like so. If I want to, this is fx prime. In that case, the angle is 70 degrees. So that is 1000 times cos 70 degree. That is fx prime. And if I want fy prime, that is 1000 sine 70. All right. Everyone is with me? If you want me to explain more, just say so. Yes, absolutely. Absolutely, Ahmed. Thank you for asking. Yes. All right. So this is a very look, Ahmed. We mentioned that there are two ways of solving a triangle. All right. So two ways of solving a triangle: A, B, C. That is angle A. This is angle B. This is angle C. Right. So we know how to solve that. This is the general case. But a specific case is when one of these angles is right angle. And that is the definition of, if this is alpha, that is y, x, this is r. Okay? So just try to remember from high school, how did we wrote the trigonometric functions here? I know that cos alpha is equal to y divided by hypotenuse, isn't it? And also, I know that the sine alpha, these are the definitions. These are the definition. The sine alpha is x divided by r. So I can manipulate these equations, Ahmed, by writing that r is equal to y divided by cos alpha. or I can write this one as x divided by sine alpha is equal to r, or I can write that the x component is hypotenuse multiplied by sine alpha, or I can write that the y component is r multiplied by cos alpha. So these are the equations you have to deal with from now on. So one way or another, Ahmed, you will construct a triangle depending what are your input or output. If your inputs are alpha and r, sine equal to no, sine is always smaller than 1, is equal or smaller than 1, right? You are right. Sine is y over r. Thank you for that. Sine is y over r. And this is x over r. Thank you for correcting this one. Yeah, you're right. So then you get x equal to r cos alpha and y equal to sine alpha. So these relationship taken from high school. We very frequently will be using these one way or another depending what are the inputs. If the inputs are the angle and the resultant, you use that to resolve that into xy component. If you are provided with xy component and you want to find the hypotenuse, you do it this way, right? So yes, that is not difficult to memorize, is it? Or in some cases, you might want to say that alpha is inverse tan of y over x, okay, if you want to find alpha. Or you can say tan alpha is equal to y over x. So when you use this, if you are provided with y and x and you want to find alpha, you find this equation. If you are provided by alpha and you are provided by x, you know that y is x tan alpha. So different way of writing the same expression, and make sure you do enough practice. And when it comes to a certain problem, you use that. Next example we have is a bracket with two links is fitted to the wall, and then you apply a force of 500 Newton at point A. The question is, what is the theta angle measured below the horizontal line such that the FAC is directed from A towards C, and the magnitude is 400 Newton. Okay, so let's try this one. Okay, I know that FAC is equal to 400. And then the question is, what is theta? All right, so I know that at point A, there is going to be three forces at equilibrium. So when I apply this force would be, this member would be in compression. All right, now I have to construct a triangle. With this triangle, I start from an arbitrary point. From this arbitrary point, I go with 500 degrees, 500 Newton here. And then I apply this force here. This is 400. And from here, this force should come back to 0, right? So let's solve this one. 500 here, 400 here, and this one is a FAB. So what do we know? So if this is 400, this is FAB, the angle between them is 60 degrees, right? And okay, so any suggestions? Okay, let's start with this one. Let me assume that this angle is whatever, I call this alpha. So if I apply the shine law here, that is 400 divided by sine of the opposite angle alpha, that is equal to 500 divided by sine of opposite angle, which is sine 60. All right. So this equation can easily be solved to find alpha. That is sine alpha is equal to 400 divided by 500 multiplied by sine 60. Okay. And if I solve that, that is 60 sine multiplied by 400 divided by 500. So that is sine alpha, but alpha is 40 degree point 8. All right, now that I know alpha, added to this one, so this is also theta. So I know that theta plus alpha plus 60 is equal to 180. So theta plus 43.8 plus 60 is equal to 180. And now by taking away 60, 43.8 from 180, you can calculate theta. Questions? Is that clear? Anyone wants me to repeat or any part of that you didn't follow, just feel free to ask me. I'm happy to explain again. Yes, yes, thank you, Nguyen. Definitely, absolutely. So, Nguyen, at point A, there are three forces, right? So this is one force exerted here, one force exerted here, and one force exerted here. We know that these three forces should make a triangle because these forces are at equilibrium. When we construct a triangle, that means these forces are at equilibrium. So you start from a point, you come back to the same point. It means the algebraic sum of all the vectors are zero. So that is the thing. The rest is you construct that triangle between these three vectors. So I know that this is theta, and so this angle is 60. If this is 60, what else can we say? So yeah, in that triangle, all we can say is this 60 is here, and we do have the angle between these 400 and 500, 400, 500, and that is all you have to do, right? Because you remember the sine law. The sine law is what? The sine law is A, B, C. That is angle A, this is angle C, and this is angle B, right? So how do you write the sine angle here? You write A divided by sine A is equal to B divided by sine B is equal to C divided by sine C. And we did the same thing here, right? Doing here, we have 400, 500, and 60. So 60 is opposite to 500. 500 divided by sine 60. How can you get that triangle? Okay. That triangle, let me construct it from the beginning. Let me construct it from scratch. Okay, I start from a point, an arbitrary point here, point A. All right, and then I have to draw parallel to this one. I draw a horizontal line. And that one, I know the length. The length is 400. So I know the end of this vector. This is 400, right? So far, so good. And then from end of this one, I draw a line parallel to this one. Right? I know that this is parallel to that one, should pass through here because my triangle closes. So from this line, I draw parallel to that. Okay? So this is 400. That one is 500. And then what is this angle? Or in this triangle, that is 30, this is 90. 30, 90, this is 60. 60 is the angle between 400 and that. So between 400 and that hypotenuse, if you like, that is 60 degrees. So this is 60 degrees. So these two angles are back to back. So this is 60, right? And that's all you need to know. 400, 500, 60. The rest, so that is parallel to this. I call this FAB. This is parallel to that 500. And this is parallel to FAC. Okay? So now the question is how to solve that triangle. Are you following how did I construct a triangle? Nguyen? Is that, or you want me to explain again? Or in a different words? If you didn't follow, that's absolutely okay. Okay, thank you, Nguyen. Anytime, if you find something not clear, that is my responsibility to make that clear. Don't be shy. Always ask. I'll be happy to explain again. All right? Please don't be shy. This is here. We are here to learn. If something is not clear, that is my fault. I have to say it with different words, different explanation to make this clear for everyone. All right, let's go on. If there is no more question, the next example is you have a bracket fitted to the ceiling, and that is taking two forces together. One force is at a 20-degree angle, and the second force is at a angle theta. So if theta is equal to 30 degrees, what is going to be the resultant? So we know that F1 plus F2 is equal to the resultant. Okay, so from here, I know that one condition is F1 plus F2 should be equal to 1 kilonewton or 1000 Newton. That is R. And also, I want R to be vertical. So this is the direction of the R. And this angle is equal to 30. So the first step of solution is simple. I write I can construct a triangle. In that triangle, I start with what I do have. The one which I have is the vertical one, the resultant. In this case, we have to start from the resultant. So let me construct the triangle by the known value. The only known value is the resultant, which is vertical. So I start from an arbitrary point here, and then I draw 1000 vertically down. So far, so good. And then from end of this vector, I'm drawing one line parallel to that. So let me draw a line parallel to that. So this line is parallel to this. And from the beginning of that, I draw a line parallel to this. So that should be the direction of the F2. This one is the direction of F1, and this is R. Okay, so in terms of the trigonometry, I know that F1 and the vertical are making it 20 degrees. And I know that F2 and the vertical are making an angle of 30. So now the question is, can I solve this triangle? The answer is yes, because this is 30, 20, 50. Take away from 180. 180, take away 30 plus 20. So this angle is 130. Everyone with me? Any problem? Can you digest that? This is 130. Okay, so that is F2. This is F1. So how do I solve this triangle? Easy. So F1, using the sine angle, F1 divided by sine 30 is equal to R divided by sine 130. And from here, I know that R is 1000. Therefore, F1 is 1000 divided by sine 130 multiplied by sine 30. What about F2? F2, that is F2 divided by sine 20. That is equal to, again, R divided by sine 130. And therefore, F2 becomes 1000 sine 130 times sine 20. Okay. Is that fair enough? Or any part is not clear? Just tell me. I'm happy to explain that again. Can you follow what we did so far? Don't be shy. If you want me to explain again, just all you have to do is to ask. Otherwise, I can only assume that you followed. Yes, no, anything? Okay. If you wish, you can simply change your status on the. So you know that there is a status bar here. Let me show you that the status bar. So this is the status bar in the Collaborate Ultra. Whenever I'm going either too fast, when I'm going too slow, when you confuse, when you want me to go, all you have to do is just change your status to one of these things. And that is a great feedback to me. I can adjust my delivery according to the feedback I get from you, right? So can you do this favor for me? Whenever I'm going, okay, go Darcy, I'm listening. Or text or use your microphone.
I just accidentally got one.
Yeah.
Yeah.
So what was your question, Darcy, again?
I accidentally clicked it. Sorry.
Oh, that's fine. That's fine.
Yeah.
That's fine.
Clicked
Okay.
the wrong
So
one.
you know how to change your status now. Okay. And then
Yeah.
one more thing, Darcy, can I ask you to approach the student quarter to get your name fixed? Because currently it doesn't show in the student one.
I think
And
it's been updated now. Like before I couldn't
okay,
see
great.
my classes, but now I can. So it should be
Okay.
fixed.
Wonderful. Thanks for that, Darcy. Thank you. Thank you, Noe, and thank you, Darcy, for changing your status. That's a big help to me. I know to adjust, to go faster, slower, or to repeat. So thank you for your feedback. All right, so that is to find out the resultant force by solving the triangle. And the trick is because you have all the angles and one side, so cos law is not usable here. You have to use the sine law. And then the next part of the question is a bit tricky. The next part of the question asks the magnitude of F1, F2 such that F2 to be minimum. So let's have a closer look and see in what circumstances F2 would be minimum, right? So imagine that you are not provided with 30 degrees. So imagine that this is not given. So if this 30 is not given, can you imagine in what circumstances F2 become minimum? And that is, I can see that if this line is rotating, the minimum number of F2 is the shortest distance between here and there, right? So if this is something like that, so if this is F2, this F2 is the smallest value. I mean, if I go beyond that, before that, F2 again becomes larger, right? So in that configuration, this angle is simply 90 degrees. So I can now solve the very same triangle to find the minimum F2. So this is F2 minimum, that is 1000. And F1 didn't change. F1 is with an angle of 20. And this is now F1. Okay, so let's find out the F1 for which F2 is minimum. So in that right triangle, I know that so how do I solve this triangle? 20, 90 is 110. 110 take away from 180, that's 70. Now that I have 70, I can calculate what I want. So F1 is equal to 100 divided by cos 20. And F2 is 1000 divided by sine 20. So who is with me? Who wants me to repeat again? All right, thank you, Darcy. What about Nguyen? What about Nigel, Flynn, Ahmed? Look, you can't say silent here. I'm here to serve you. Just the only way I can serve is you tell me, Shaheen, you are going too fast. You didn't explain enough. I'm confused. Or, okay, Nigel, thank you. Nguyen, well done, well done. Yes, yes, you want me to explain again. No problem at all. No problem at all. Let me do that again. Look, the second part of the problem says, look, ignore what I told you. If we don't know theta, you know that theta can change. For what value of the theta, F2 is minimum? And all you have to do to answer this question, Nguyen, is by looking into your triangle. So in that triangle, imagine theta is where? Theta is 30 degrees. This is theta, right? So if theta is not 30, can you visualize what happens if theta becomes larger? If theta becomes larger, this line becomes more horizontal, more horizontal. Suddenly, at one particular value of the theta, this vector becomes fully horizontal, right? And if you go beyond that, again, F2 starts to grow. So at one particular scenario, that is when this angle is 90 degrees, this F2 compared to this F2 compared to the next one, the minimum is this one, because the shortest distance between 2 points is when you draw a normal from that point to this line of action. So that compared to this one, of course, this one is smaller. If you go beyond, again, this is larger than that one. The shortest F2 would be when you get this one at a normal angle. And in that case, I simply constructed the free body diagram again and solved these to find out the forces. So this is, Nguyen, all matter of visualization. Okay, thank you for that. So here in the part one, it told you what theta was. In the second part, it asks you to visualize how the variation of the theta would change the magnitude of F2. And so the angle corresponding to its minimum value is the 90 degree. Thank you, Nguyen. Anytime, stop me if I'm not explaining good enough. All right, let's go to page 45, and then we have a couple of fundamental problems to solve. Page 45, 1 to 6. So this is page 45. We want to solve between 1 to 6. So 1 is simple, and it becomes little by little more difficult. Just give me a number and tell me which one you want to start with. You want to start from simple 1, or you want to go something medium like 3, 4, 5, or you want something difficult like 6? Medium. All right, let's go to, for example, I think 4 is medium enough. Let's go to 4. All right, you've got a force 30 degrees, and then you want to resolve that into 2 components along the u and v axis. So when it says u and v axis, it means you have to construct a parallelogram in which u and v are 2 sides. So all you have to do is, so u is horizontal, and the force itself is at 30 degrees. And this is 30 Newton. That's 30 Newton. And then the V component, this is F of U. This is when you project F in U direction. So this is the U direction. But then the V component is parallel to that. So from end of this one, you draw a line parallel to that. So from end of this vector, I draw a line which is parallel to V. And when I say it is parallel to V, it means this angle is 15 degrees. All right. All right. So this is going to be component of F over the V. This is the component of the F over U. So how do I solve this triangle? First of all, everyone is comfortable with the way I constructed the triangle. If not, just let me know. So here I know that this angle is also 15 degrees. That is 90 degrees. So 90 degrees plus 15 degrees, that becomes 105, correct? So 105, 30, the next angle would be this is 135, take away from 180, that is 25. Or 45. So alpha is 45 degrees. All right. And now I can solve this triangle, can I? So how do I solve it? That is by the sine law. So by the sine law, I have component of the u divided by sine 45 is equal to 30 divided by sine 105. Okay, so from here I find out the component of the f over u is 30 over sine 105 times sine 45. And then I can write the sign again for the next. This is f of u, f of v, sorry. This is f of v. F of v divided by sine 30 is 30 divided by sine 105. And from here, we get the v component is 30 sine 105 times sine 30. Okay, questions? Thank you, Darcy. What about Flynn? What about Ahmed, Nguyen, Nijil? Are you comfortable? Thank you, Ahmed. I assume Flynn, Nguyen, Nijil. Okay, thank you, Nijil. Let's go to, thank you, Nguyen. We go to something a little bit tougher, and that is number, or maybe I go with, let's see if we have more slides. Okay, we go to page 46 to 48. Let's try 46. 46. All right, 46. I think this problem could be examinable. 2-5. Okay, so what is this question about? That is, this is a knee structure. And then the force acting is 360 newtons. And you want to find out its component along x prime and y axis. X prime, y axis. So let's do that. So if this is 10, I know that two mutually perpendicular angles are equal. So that is from the geometry. It means this angle is equal to 10 degrees. So what it means is this angle is 10 degrees. And now if I want to project f over x prime, all I have to do is 360 multiplied by the cos of this total angle, cos 60 plus 10, which is cos 70. All right, so that is fx prime. What if I want to find this fy? So fy, I need to account for 60 degrees. So this is y. So that is the triangle. This is fx, this is fy. So in that case, fy, that is 360 multiplied by sine 60. Okay, make sure you understand this. If you need me to explain again, all you have to do is to ask. Okay, good, good. Yes, let me explain again. Okay. All right. So we know that x and y, they are perpendicular. We know that x and y, they are a orthogonal coordinate system. And we know that x prime, y prime, they are also mutually perpendicular. All right. So what it means is if I rotate y angle by 10 degrees, x prime would rotate by 10 degrees. So that is in a simple word. So we have two coordinate systems. One coordinate system is xy, the other one is x prime, y prime. Here, for some reason, you want to break this one into two different axes which are not. Once you want it over x prime, once you want it over x. So to project it over x prime, all I have to do is I draw that force where it is. This is the force. And then I have to draw the x prime line. So x prime, how do I get to x prime? This is the horizontal x. To get x prime, I have to go further 10 degrees, right? And now that is 60 degrees. This is 10 degrees. So far, so good. That is 360. All right. Remember, how do you project? This is x prime. This is x. How do you project this? All you have to do is you have to draw a normal from here to this one, not to this one, because you want to project 360 over x prime. So let me draw a normal over this. I draw a normal. So this is normal to that. Normal. And all I'm asking is this one. This is called fx prime. So fx prime, here I have a triangle. In this triangle, that is the right angle. And fx prime is hypotenuse multiplied by sine of this angle. So what is the sine of this angle? Or what I need is that multiplied by cos of this angle. Cos of this angle is 60 plus 10, 70. So that is 360 times cos 70. That is 60 plus 10. In the second instance, I want to project this one over y. So how do I project it over y? So let's start with the force again. That is the very same force, 360. So how can I draw over x prime? Yeah, well, that is, let me zoom in here. Okay, so when I say I draw over x prime, when I say I project over x prime, what it means in simple term is the angle between the line which I draw and the x prime is 90 degrees. So if this is 90 degrees, this one is also 90 degrees, right? So now you have to solve a right angle triangle. So in this right angle triangle, that is what you have. This is x prime. This is the dotted line, and that is the hypotenuse. The hypotenuse is 360, and this is x prime. And this angle is 60 plus 10, that is 70, right? So 360 multiplied by cos 70 is the projection over here. All good? All right. So, Darcy, is that clear? All right. Very good. Very good. So we only do one more, and then I let you go. So let's go to page 480, and we choose something from 480 over there. So let's, for example, try this one, 219. All right, we have two forces, and we want the resultant force to be minimum. So let me get the question clear again. Resultant force to be directed toward the positive x. So we know that resultant is going to be horizontal, and FB to be minimum. Okay, very similar to what we did before. So I construct a, that is the resultant, but I start from the known force. The known force is this one. That is 2 kilonewton at 30, right? So that is 30. And that is 2 kilonewton. So in what circumstances FB is minimum? If this is, so I have to, yeah, the minimum FB is when FB is normal to this one. Otherwise, any other FB, I mean, the third side of the triangle would be FB. You could have FB like that, you can have it like this, or you can have FB like that. The minimum FB is when FB is perpendicular to this one. So that is the resultant. This is the FB. And now we can solve it. I mean, how theta comes into this? The theta is the angle between FB and the x-axis. So this is theta. So when theta becomes 90 degrees, FB is minimum. And that we can easily solve, right? 2 kilonewton is the hypotenuse, 30 degrees, and that is the resultant. Or FB is 2 kilonewton times tan 30 degrees. And the minimum theta is 90 degrees. All right. Everyone with me, or you want me to explain in a different way? So all you have to do here is you need to draw a triangle which shows FA resultant FB in equilibrium. In general case, your equilibrium would be like that. So this is R, this is FA, and this is FB. And what is theta? Theta is the angle between FB and, so this is theta, right? So now you wonder what theta makes FB minimum. Just visualize as you change theta, make it this larger, smaller. If you make this smaller, FB becomes taller. If you make this smaller, it gradually moves to the left, and suddenly at theta equal to 90 degrees, FB becomes minimum. All right, so that is almost all I wanted to cover. If there is any question, please ask me. So let me see if we have your name updated, Darcy. And yeah, now I have your name. Thank you for that.
Cool, thank you.
All right, so for today, Sehrish was here a few minutes, Natasha away, Nguyen here, Aiden away, Chaisal was here, Daniel away, Abdullah and Jay away, Jonathan away, Ahmed here, Nigel here, Barnaby away, Flynn was here, Shah was away, Darcy here, Porty here. Okay, so today we summarize the addition of the vectors by the method of triangle or parallelogram. And depending on the circumstances, you construct the triangle. And that triangle, you either would use the cos law or the sine law, depending what are your inputs. And yeah, so next class, that is tomorrow, 10:30, we go through other methods of adding the vectors like Cartesian components. Any question before I close the class? No question? Thanks very much for being the part of class. Very good. Thank you, Darcy. Thank you, Flynn. Thank you, Nguyen. Thank you, everyone. And if you need to watch the recorded sessions, I record all my tutorial and lectures. You can watch them anytime you want, if that helps. Thanks very much, and looking forward to see you tomorrow. Take care. Bye.